What's going on YouTube? Welcome to the workroom. As promised, without any further delays, the Super TMC on the inside. Part that counts. Before I get into any of this though, I'm going to give you guys a safety disclaimer, and you're going to want to hear this because I had an unfortunate mishap doing this. Don't do this at home. 100%, okay? I'm telling you not to do this at home. Take it to a machine shop, because I had a pretty scary run-in rather, with a sliver that managed to get into my eye, even though I was wearing a face shield and safety glasses. And I had a vacuum running next to the Dremel to try to suck up some of the chips as they were coming off. If you've ever Dremeled anything before, yeah. So I did this at home with a Dremel. Drill bit set, couple random mismatch from around here, and I was able to make my TMC shoot first strikes. But I wasn't out to just make the TMC shoot first strikes. No, I wanted to create something super. So inside this gun, you're going to see a lot of mods that probably won't make sense, and I'm going to be flip-flopping around back and forth. So make sure you stick around to the end of the video, because there is a lot of useful information I might forget to go over, but I might cover it later on. I'm just going at this freehand, unscripted, so without any further ado, let's talk about the Super TMC. Right after I remind you, please don't do this at home, even though I did it with a Dremel. Having a, 3/8 long zinc sliver in your eye is not fun. Okay, so here we go. Okay, everybody, so this is the inside of the Super TMC. I'm going to come along with my screwdriver and point out some of the things that are different from your TMC. First of all, I'm running a heavy-duty valve spring inside of the valve body here, which I had also modified. I actually did 2 valve bodies. And you might notice something about this particular valve body is that the outside is chamfered inwards, okay? It's not just a straight 90-degree angle edge. Both of this one and this one, which is a spare, are chamfered, excuse me, a little bit. And that is to allow easier entrance of the hammer and hammer O-ring to work its way into here, and I was hoping, I could be wrong, but I was hoping that this would help reduce the amount of shearing that the O-ring had endured going in and out of the valve. Normally when something goes wrong with a Tippmann like this, it's the hammer O-ring, and it doesn't surprise me because the amount of shearing that goes in. Now, whether that's just a far out there left field theory is beyond me. I haven't fired this enough to find out if that actually makes a difference or not. Okay, so one of the other things you probably can't see on camera, and I'm probably going to lose them pulling them out, I've got to take this apart anyways, is I have a double trigger spring. 2 of them. Now, I'll explain why in a minute or two. But along with the trigger spring, I actually have 2 of these rods, and I was experimenting with a long throw rod, so one that was probably just 4 millimeters longer than this one, and what that would do was take up all the slack in the trigger. But I found out that that wasn't necessary. Again, I was on a quest for full auto. So this right here is just the standard bit. Again, your standard trigger. Nothing special to see there. Okay. Standard trigger. We have the charging handle. Okay. Now I have several bolts. Okay, this happens to be the latest upgrade from MWR Paintball. This was not the one that was in the marker when I shot the video, but it will function just the same. This is a 3D printed bolt. And if you were to buy the kit from MWR Paintball, you get this bolt and which is a first strike round bolt, and this bolt, which is a round ball bolt. Okay, you can fire round balls with just this bolt, but if you're going for more air efficiency and you're only using round ball only, I would use the longer bolt because it travels further into the barrel before the hammer strikes the pin on the valve, and that will give you a better seal in the barrel, and you won't waste as much off-gassing around this area here. Okay, now you can't tell right here just by looking at it, but I actually had to shorten the power tube. Okay, I had to cut it, and I'm going to show you guys exactly how to measure up for your conversion. Even though I recommend you get a machine shop to do it, you can probably cut this at home with, well, an X-Acto knife if you're determined enough, a hacksaw, or anything really. Okay, so now let's remove the power tube. As you can see, I did chamfer and polish the inside of the power tube. I've had this apart several times, so I've got a hefty amount of Teflon tape here. I had a leak down problem. I left the air tank on my marker overnight and it went empty, and then I later found out that it was the tank and not the marker. Nothing special to see with you know what, I don't even know what this is called. It's kind of like a it flips the sear. One of you guys want to let me know in the comments below exactly what this piece here is called. That'd be perfect. Okay, that piece is unmodified. The sear is also, believe it or not, unmodified. I seen somebody in the comments section saying that this was a full auto sear. Nope, this is the standard sear that came with the TMC. Now, what you probably notice I have different on mine that you probably don't have done on yours is I have a threaded hole here. Okay, I'm going to try to zoom in post filming and show you this hole. Why do I have that hole? Okay, if you look really close at the engagement of the sear on the hammer, this is your hammer, custom hammer by the way. Okay, when I thread this bolt, and again, take a look at it. Okay, it's not perfectly square. I had to taper it. And this was where I got the full auto from. Sorry. Okay, so I screw in that bolt. And what you'll notice starts happening as the bolt starts coming through down here, it's going to push the sear upwards. Okay. Now, I'm going to have to do something in post-edit so that becomes like apparent to you guys. But you can see that the sear isn't resting square on the stop pin, and now it's only engaged at, say, 20% onto the hammer. Okay. And what this allows me to do, excuse me, is to bump fire the marker. Okay, I know in the video it looked like full auto, but it actually wasn't, and I never did claim that it was full auto. It's actually bump fire, but a bump fire or a forced reset trigger or a response trigger is just another form of shooting a lot of projectiles really fast without having to do the work. The problem is with this is that there's no way to adjust the balls per second. Okay, so it goes full ham until your magazine is empty. Now, I seen somebody write a comment that I was just making a blender. Well, if you take the empty chamber discharge prevention device, okay, and it is installed like such, up here on the top of the marker, it cannot blend. Because if your projectile isn't sitting firmly into the chamber, okay, that's going to come down a bit and it's going to stop the bolt from traveling forwards so that you don't waste any of your air. Because I believe that's what the intended purpose of the unit was. Okay, so that functions like so. So it can't blend. It will literally run until it's out of ammunition. Okay, or you could get lucky and release the hammer or release the trigger, and this here will come up and catch it. Okay, in the video where I showed you, it ran itself dry and it stopped in the manner that I showed you using the ECD PD. Okay, and behind there, I have a custom. No, I didn't customize it. I bought this from Tippmann parts or TechT. Check out Tier 1 Armament. They now stock TechT parts. But I had an entire plethora of springs to go through to check out. Here, I'm just going to reach for some and show you by example. Okay, I had some springs. A lot of springs. More springs than I'll ever know what to do with, that's for sure. Okay, so there was some issues about getting the marker to recock at first. So I found out I was using a spring that was actually too lightweight, if that makes any sense whatsoever. So there was that. The hammer itself is the original equipment hammer. Okay, I drilled a lot of holes in it. If memory serves correct, this guy weighed 144 grams in its stock configuration. Okay, and I know that you can buy hammers from TechT. They call it a zero kick hammer. But I literally just turned this one into Swiss cheese, as you can tell, using a drill press. And then I had to sleeve it. I actually got my friend Anson to sleeve this for me. I'm a bit of a ham fist when it comes to these high tolerance press fit applications. And what that sleeve does is it stops the spring from binding up, because it will bind up and it will stop your marker dead in its tracks. Now it weighs 94 grams if memory serves correct and functions just fine. Now you might be asking yourself, okay, if you look here, you'll see holes that go through. Well, does this affect the blowback? The answer to that question is no, because all the blowback gas actually stays behind the O-ring here on this side until it gets out more into, like, I'm going to call this the combustion chamber, even though that doesn't make any sense. And then some of the gas can escape out here into the marker, which is, it does that from the factory anyways. This surface right here was highly polished until I realized that my hammer was scoring it up. And then somebody made the comment about it looks like I went at this with a Dremel and chewed it all up. Well, I did, because there was, from the drilling process, some burrs that were sticking up out here. So I didn't have a countersink this big, so I just went at it with a Dremel, kind of grind it down on a chamfer so that it would stop gouging out my cylinder bore here, and it is polished even up into the backside here, fully polished. The same with the front here. It was highly polished before I started working on it to get it to shoot first strikes. Okay, the shooting the first strikes part, which is what you're interested in. Now, mind you, you don't have to do any of what I had done to my marker to get it to shoot first strikes. You really just need to clearance. All right, let's say that again. To get your marker to shoot first strikes, okay, you don't have to do anything of what I had done to it. Okay, guys, how I ended up cutting my D-shaped window and figuring out where to put the winder release, because believe it or not, the factory one with the TMC does not work. And you have a bar of some sort that sits across here to push on the trapdoor of the TMC magazine. So obviously that has to disappear. So what I found initially was that the magazine was too wide. Okay, the magazine was too tall. Tall is the right word. Okay, the mag was too tall for the mag well as it sat, but width-wise was just fine. So what I did was I came across both sides of the mag well, just the sides. Yeah, I come across gradually on both sides of the clamshell until I got a fit where I could slide the mag in nice and perfect with it bolted together. Okay, don't try to do this with just holding both halves of your marker. It's not the same. You gotta bolt it together Okay, don't just hold both halves together and go, okay, it fits. Okay, no, you want to squeeze that because it actually makes the difference. I found out the hard way. Okay, you don't have to put the guts back into it when you're doing that. You just got to put the bolts in and then torque them up to spec. Okay, so enough of that. Got a dirty mag here. Okay, so what you want to do, okay, as you're doing this, is you want to put your mag in and push it down all the way. And then what that's going to do is it's going to show you where the D window is, okay? I don't know how well you guys can see that. But you're going to mark that off underneath your marker, okay, where you want your D window to go. And then what you're going to do is you see where the mag release, or the winder release is, the button. You're just going to mark that off, okay, with a paint pen or some sort of apparatus that you can, that will stay there. So mark it all the way down to here, okay? And then for the trapdoor release, because I mentioned that mine weren't cannibalized in any way, shape, or form, I don't know how well you're going to be able to see this because it's really shiny in here, is there's a set screw right here, okay? I drilled all the way through here, and then I tapped it, I think for a 10/32 set screw, and then I came into the top. Oh, I used some JB weld, okay? I used some JB weld so that it wouldn't take off. I let that cure for 24 hours, you know, just to seal the threads. And then I ground it flat so it wouldn't interfere with my bolt at all. And what that does is it pushes the trap door back all the way open. You see that? You see how the trap door just opened all the way there? So what you're going to do for this half of your receiver is you're going to line it up, and then you're going to look at where your trap door is. The bump that sticks up on the trap door, and then you're going to mark that off on the receiver. And then what you're going to do is you're going to come up to the top, like so, and like I had explained, drill and tap yourself in a set screw, JB weld it, leave it there. Okay, and what that's going to do, oh, and I also ground this on a bit of a backwards taper. Okay, because what I found was a flat set screw was digging into the plastic of the magazine and causing insertion issues. You know, insertion issues. So I ground it on a bit of a backwards ramp to allow the trapdoor release to sort of slide downhill, if that makes any sense. So as you can see, it works good. Maybe I should push the button. There we go. Every time, full-size trapdoor. Okay, it grabs it and moves it back. That's super important. So back to this piece right here, the winder release. What this is a countersunk style, not a set screw, but it's like an Allen head screw, you know, with the, I'll put a picture of it for you on the video, and it's an 8mm. Now what I did was I drilled all the way through the marker, okay, and then I tapped that hole, and in the opening that was milled out by the Dremel, again, you guys are going to get a machine shop to do this because I don't want you getting hurt, and I assume no responsibility if you do so. So you're going to screw that in to the required depth, and you'll know how far to screw it in. Okay? And then what you're going to do is you're going to take the fastener all the way out again, and you're going to mark it for length, and then you're going to cut it. And you're going to put it all the way back in, except you're going to use some JB weld as thread lockers to hold this in place. Now you're going to wait. You're going to wait the full 24 hours to allow it to cure. Once it has cured, then you hold this fastener with an Allen key through the top, and then you come along with your Dremel, and you square off the top, again, because you don't want any bolt interference, right? And then you kind of make like an L shape here. Because, again, this is metal, and it's never going to come off. This isn't a 3D printed part. This is going to last forever because it's metal, okay? And all you need is the tiniest little tip to reach down inside of the magazine and then push that down. Okay, so as you can see, And I don't know how well you can see it. I just keep saying, as you can see. No, I don't know if you guys can see this. It is flat in here, but there is a bit of a hump sticking up here. Again, all done with a Dremel, and it's not complicated. This screw will probably cost you 50 cents at a hardware store. You can get it in any thread pitch you want, although I said I used 8mm. Okay, you can use 10/32 or 10/24. Oh no, in this you're going to want to use 10/32 because fine thread. And the tap to get that done. And I think that is that with regards to the marker. As always, I can be reached on MagFed Paintball and the Facebook group. I have just also started a MechTactical Facebook page. Head on over there and join my 4 followers. And let's see if we can make something out of this. Again, thank you for watching. If you didn't, I wouldn't be doing this. See you on the next one.